Hello again. This video is going to be over the simple machine wedge. A wedge functions as a moving inclined plane. It tapers to a thin edge and is used for splitting, raising heavy bodies, and for tightening by being driven into something. There are two kinds of wedges. The single wedge, here, as you can tell, looks just like an inclined plane, and the double wedge, this one here, where you can tell it's two inclined planes put up against each other. Here are a few examples of a wedge. This image explains what distances to measure to find the IMA. The distance resistance is found right here. It's the distance traveled by the load. As the wedge moves farther into the material, it is going to cause the material to move farther apart. The maximum distance that the material will move apart based on the wedge itself is going to be the height of this wedge. Just like in the inclined plane, your distance resistance is the height of that inclined plane. The distance effort is the distance traveled by the wedge. So the maximum distance that the wedge can travel is going to be the length of the wedge. So we're going to measure the length of it, not the hypotenuse like we did with an inclined plane, but instead we want to go from the larger end to the smaller end, just finding the length of it. The IMA of a wedge is a ratio. Even if we do not move the entire wedge into the material, it would still be the same ratio. This can be explained by the similar triangle rule you used in the inclined plane investigation. The distance effort is going to be, again, the length from the large end to the small, and this problem tells me it is 10 inches. So I place this here for distance effort. Distance resistance is going to be here, the height of my wedge. And it tells me in the problem it's 3.0 inches, so I place that here. My inches cancel out. 10 divided by 3 is 3.3. So the ratio for my IMA is 3.3. It really doesn't matter if it only went in to this far, because if I was to do the math and call this my height and this my distance, it would still come up with the same ratio of 3.3. If you're raising an object with a wedge, the force resistance would be the object's weight. But if you are splitting an object apart, the force resistance would depend on its strength of its intermolecular forces. In this case, the force resistance will be given to you, like in this problem here. So our force resistance is given to us as 700 pounds. We're going to find the actual mechanical advantage, just like you have in all the other problems that you've learned before. AMA is force resistance over force effort. So our force resistance was given to us of 700 pounds. The force effort may be applied with a hammer or being pushed in by your own weight. In this problem, it is 250 pounds. 700 pounds divided by 250 pounds is going to be 2.8. Notice that my pounds are going to cancel out, leaving me with no unit. Now with those two values, the AMA and the IMA, I can find my percent efficiency. My AMA was 2.8, IMA is 3.3, so 2.8 divided by 3.3 times 100 is 84%.